Hello, we're ready for section 2 of chapter 4, titled Operations on Functions. What we're going to do in section 4 is take two or more different functions and start combining them together. If you look up here in the upper left hand corner, you'll see that the sum of any two functions, the first function f, the second function g of x, is the same thing as taking f of x plus g of x. Difference works the same way. F minus g of x is the same as taking f of x minus the second function g of x. If you want to multiply two functions, f times g in terms of x, then just take f of x times g of x. And finally, if you want to divide functions, f divided by g of x, then take f of x divided by g of x. Now, a little note there, g of x is not allowed to be 0 because it's in the denominator, and you guys know that if the denominator equals 0, then you got problems. Finally, the most important part of this section, composition. If you have f circle g, now that's not an O, that's a circle. I call it the fog. It's the composition of f and g. That's the same thing as taking the function g of x and plugging it into f. Taking g of x and plugging it into f. Whereas if you have g composed with f, g circle f, or in short you can call it the GOF, that's like taking f of x and plugging it into g. Now, one way to think about it, take number 4, bring it down here. That's where x is the domain of g. X is the domain of g. Oh, I wrote that wrong. Erase g right there. I meant to write domain. X is the domain of g. In other words, it's the input. It's the input of g. And then g of x, or y, is the domain of f. So it's like a two-step problem. You plug in x into g, and then you take that answer and you plug it into f. And then number 5, you just turn it around. X is now the domain, or the input, of f, and then take that value, that y value, and plug it in to g. Alright, so let's see this happen. Let's see this all in action. So I've given you two functions up here in the upper right hand corner. 4x squared minus 2x is f of x, and g of x is just 2x. So find f plus g of x. F plus g of x. That means to take f of x and add it to g of x. Okay, well, f of x is 4x squared minus 2x plus g of x, which is 2x. Well, 4x squared minus 2x plus 2x, they just cancel the 2x's, and answer is 4x squared. Sweet. Alright, awesome. Let's go to the second one. This is where you subtract them. So now you have f of x. F of x is 4x squared minus 2x. Put it in parentheses, it might help you. Minus g, and g is just 2x. Now the part people get caught up on here is if g of x has more than one term, they forget to distribute the negative. Here g only has one term. So this becomes 4x squared minus 2x minus 2x. Final answer, 4x squared minus 4x. There you go. You have just subtracted those functions. In part C, I want you to multiply the functions. Multiply the functions. I'm going to do it in red. That means to take f of x, which was 4x squared, minus 2x, times g of x, which is 2x. And here you just distribute. So you're going to get, let's see, that'll be 8x to the third power minus 4x squared. And it's as simple as that. That's all you got to do. You're done. Alright, part D is a little bit trickier. Let's go back to yellow. This says take f over g. So that means take the top function, 4x squared, minus 2x, divided by the bottom function, 2x. Now you should always factor here if possible. You should always factor if possible. Let's see here. That means the top you can pull out a GCF. You can pull out 2x. That leaves you with 2x minus 1. And on the bottom you still have 2x. Well, guess what? You can play hack and slash now. those two x's disappear, and you're just left with 2x minus 1. Now, one little note you need to make here. Remember, we started with 2x in the denominator. That means x is not allowed to be 0. There's a little restriction on the domain there, and you need to make that restriction. Okay, none of the others have had restrictions on the domain, but there we do have a restriction. Alright, and now finally, these are the tricky ones. Find f composed with g of x. Find f of g of f. That's what that means. Find f of g of x. This means to take g of x, folks, and plug it in to f. Take g of x and plug it into f. So what was g of x? It's up here. G of x is 2x. So you're going to pick up 2x, and everywhere you see an x in f, you're going to replace it with 2x. So here we go. Leave f alone. Put 4, and then instead of x squared, you're going to put whatever g of x is. What is g of x? G of x is 2x. G of x is 2x. Now that was squared minus 2, but then instead of x, what do you put again? You put g of x again. And g of x was 2x. So let's review here. What we've just done up here is take 2x, and everywhere you see an x in f, you replace it with 2x. You kind of work inside out. We started with g, and we put it into f. We started with g, and we put it into f. And now you just have to clean this up just a bit. Okay, so 2 squared is 4, times 4 is 16, x squared minus 4x. And that is f of g of x. That's f of g of x. Okay, let's try the last one. This one, I turned it around, find the goth. So now, start with f and plug it into g. Let me write that out. G, we're going to start with g, but then inside of it, we're going to put f of x. So we're going to plug f. F of x becomes our domain into g. We're going to plug f into g. Alright, so start with g. G's up here. I'm circling it. It's 2x. So just put 2, but then don't you dare put x. What do we put inside there? Don't put x. Put whatever f is. I'm circling it at the top. That's 4x squared minus 2x. And now just simplify it. Clean it up. So distribute the 2 and you'll be done. That's 8x squared minus 4x. You all just composed functions. Awesome. Composition of functions is where you take two functions and you combine them together. Let's go over to the left-hand side of the screen. Go over to the left-hand side of the screen. It says to find g of f of 3. Well, I want you to pretend for a second like the g's not even sitting there. Cross it out. You don't have to cross it out, but I'm going to. So just pretend all this says is f of 3. Do this first. Okay, well, f of 3, that means to take f and replace x with 3. So 4 times 3 squared minus 2 times 3. That is 36 minus 6. That answer is 30. Are you done? Yes or no? No, wait a minute. Now erase the g, where we marked out g, and bring the g back to life. Now we're going to find g of 30. It was the range for f, but it's the domain for g. So plug in 30 now, and you'll be done. Well, g of x was 2x, so it's 2 times 30. Answer, 60. Boom. That's your final answer. That's g of f of 3. So instead of just using one function, we're now using two functions. All right, I want you all to try the next one on your own. I want you to try letter H. Pause the video and try letter H. F of 3. F of 3. Okay, let's see if you did it right. Well, cross out the first f. Forget about him. Start with the inside. So, we're going to do f of 3. That means 4 times 3 squared minus 2 times 3. Well, I believe we already did that in the last problem. That ended up being 30, I believe. So if you did that, great job. However, you're not done. What must you do now? Oh, wait a minute, Mr. Williams. That's only one step. Now I have to take this, now I have to operate on this outside f. So take the outside f and plug in this answer you got, 30. Check that out. Now I do it again. 4 times 30 squared minus 2 times 30. Oh boy, 30 squared is 900 times 4 is 3,600 minus 60 would be 3,540. If you got that right, give yourself a pat on the back. If not, I want you to go back and try it again. Very good. 3,540. Okay, in this next slide, we're going to have a little fun. Alright, let's read the problem with me. Let f of x be the function x to the 4th minus 3x squared. Let g of x be the function x, the square root of x minus 2, the whole thing in the square root. Find f of g of x. Find the fog and give the domain of the composite function. So we're going to find f of g of x. We're going to find the fog. What that means is to take f on the outside and on the inside put g of x. We're going to work inside out. So we're going to pretend the only thing we see is g of x. Can you cross out this f for me? Can you just pretend all you see is g of x? And we're going to replace g of x with what it is. What is g of x? Oh, it's up here. It's the square root of x minus 2. Cool. Alright, now you're going to take this hunk of junk and plop it into f. But f is this nasty piece of junk right here. Okay, so it's going to be, instead of x to the 4th, I have the square root of x minus 2 to the 4th. Minus 3 times, instead of x squared, the square root of x minus 2 squared. Square root of x minus 2 squared. Well, can we clean that all up at all? Right here, square root and squared, they undo each other. So this just says minus 3x plus 6 right there. Ask yourself if you know where the plus 6 came from. Because the square root disappeared with the squared. Now, can we clean this guy up at all, this first guy? And we can. I want to make a little side note right here. From Algebra 2, do you remember what a square root is as a power? Do you remember? If you rewrite this as a quantity, x minus 2, if you're taking the square root, that's the same thing as the 1/2 power. 4, the square root, same thing as 4 to the 1/2 power. Answer 2. That's just a little side example. Alright, so now that we know that, let's rewrite this as x minus 2 to the 1/2, the whole thing to the 4th. And now when you have a power to a power, you can multiply the powers. So that says x minus 2 squared. Multiply the powers. Well, now we got something we can work with. Do some FOIL here. That's x squared minus 4x plus 4. All I did was FOIL. I still have minus 3x plus 6. Now combine like terms, x squared minus 7x plus 10. That is your composition, x squared minus 7x plus 10. But be careful, I asked you to give me the domain. And what's the domain? Now the domain has to work for the entire function, including its original form. Including its original form. So look back at the very, very beginning to find our domain. Look right here, guys. That says the square root of x minus 2. What is x allowed to be? What is x allowed to be? Well, set it equal to 0. X starts at 2, and what happens? Does it get bigger or smaller? If it gets bigger, you get numbers like 3, 4, and 5. If you subtract 2, you can still take the square root. But if x gets smaller, like, negative 1 minus 2, can't do the square root of that. Can't do it. Can't do the square root of that. So that means the domain is all x's such that x has to be bigger than or equal to 2. Even though, if you just look at this function, you might think all reals. It's got to work for the original 2 functions that we composed this new function with. So if we just had this function, you'd say, oh, well, domain's all reals. You can plug in whatever you want, Mr. Williams. But it's got to work for these first 2 functions. It's got to work for f, and it's got to work for g, not just f of g. not just f of g. This guy down here is f of g. All right, awesome, awesome. Very cool stuff. Okay, last example. You're probably going to need to pause the video and copy this picture very, very closely. Copy this picture very, very closely. So up here in this picture, I assumed you've already paused the video and copied the picture. Up here in this picture, I've got two functions. I've got a green function right here. That's my g of x. That's my g of x. Y equals g of x. And I've got a yellow function right here. It goes up to 2. That's a point -1, 2. That's my yellow function. Okay, that's my yellow function. So, for instance, like we can say, okay, that point right there that I just pointed to, we would say f of 3, the input, the x, is the same as 2, the output, the y. That's how you read these ordered pairs. Remember, f of 3 being 2 is the same thing as saying the ordered pair 3, 2. Those are the exact same thing. That's going to really help you in this problem. Okay, what I want you to do in part A, up there in red, do you see it here in part A? Find f of 3. Okay, f of 3, f of 3. That means my input's 3 right here. Fine, and I want the f, that'd be the yellow one. Oh, that's right there. F of 3, the y value is right here. Oh, it's 2. So f of 3 is 2 minus g of 3. Okay, g of 3 is the green function, so go right here to the arrow again. Wait a minute, g of 3 is on the x-axis. That means g of 3, the output there, is 0. Let me write that here. F of 3 was 2, because that's the y for at x equal 3. And g of 3 was 0. That's the y at x equal 3. So 2 minus 0, 2. F of 3 minus g of 3. In other words, if you take the yellow function minus the green function at x equal 3, you get 2. At x equal 3, you get 2. Okay, alright, here we go. Now, we're ready for the blue part. Ready for the blue part. When is f of x minus g of x positive? In other words, when is, now let's see here. When is yellow minus green a positive number? Well, that's when yellow is above green. Think about that. That's when yellow is above green. When yellow minus green is a positive number, that's when f of x minus g of x will be positive. Alright, so let's find all the places. Here we go. Here's my arrow. Right here, guys, in this domain from -1 to 0, is yellow above green? Yes or no? Is yellow above green? Yes or no? It is. That's from blank to blank, from -1 to 0. From -1 to 0. So -1 less than or equal to x less than 0. Don't put equal to, because at 0 is where they cross, up there in the top left corner. Alright, where else is yellow above green? What about from here to here? Is yellow above green? I don't think so. What about from 2 to 5? 2 to 5. Is yellow above green? Yellow above green? It is. That's where f of x is higher. So that's another spot. From 2 less than x less than or equal to 5. Less than or equal to 5. That's where yellow is above green. Notice, I didn't put a less than or equal to the 2. Okay, next question. When is f minus g negative? Now what this means is this is where green will be above yellow. Where green will be above yellow. Because if you take yellow minus green, and green is the higher number, well, yellow minus green would be negative in that case. Okay, so yellow minus green. That would be in this window right here. Here's yellow minus green. So you take a lower line minus an upper line, and you're going to get a negative number. So that's from 0 through 1 to 2. From 0 to 2, that's when yellow minus green is negative. So 0 less than x less than 2. That's when yellow minus green is negative. That's when the f of x function minus the g of x function is negative. And finally, when is it equal to 0? When is it equal to 0? Well, that's when yellow and green cross. Where do yellow and green cross? Boom, boom. That graph's getting crazy now, isn't it? But where do they cross? Where are they equal to each other? Two places. At x equals 0 and at x equal 2. I think you have one problem in your homework tonight just like that particular scenario. Alright, and finally, let's do this part C. It's in this funky looking salmon color. Graph f of x plus g of x. So take the two f. Now remember, that means to take a y value plus a y value and get a third new y value. So what you're going to have to do is go through your yellow function and trace it and get all the different y values for all these x values. So at -1, yellow is up to 2. So put 2 right there. At 0, yellow is up to 1. At 1, yellow's down here, the y value is 0. At 2, it's up here at this crazy point where I already have a whole bunch of circles, back to 1. At 3, it goes up this high, it's at 2. At 4, it's still at 2. And at 5, it's still at 2. Alright, sweet. Now let's do the green function. At -1, it starts out on the x-axis, so it's equal to 0. At 0, it goes up here to 1. At 1, it's still up here, hovering straight across, so that means at 1, it's at 1. At 2, it's still at 1. At 3, though, it comes back to the x-axis, so it's 0. And then it just stays on the x-axis for 4 and 5, so it's still at 0. Now find a third function, f plus g, you can call it h if you wanted to, and add all the y values. So add this column plus this column to get our new function. 2 plus 0 is 2. 1 plus 1 is 2. I put 1. Let me erase that. That's pathetic, Mr. Williams. 1 plus 1 is 2. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 0 is 2. 2 plus 0 is 2. And 2 plus 0 is 2. Alright, so now all we have to do is literally sketch all these ordered pairs using these x's and these y's. Bunch of 2's. These x's and these y's. So, -1, 2. Right about there. 0, 2. Right about there. 1, 1. Right about there. 2, 2. Right about there. 3, 2. The next y value is also 2. And the last y value is also 2. And then you just play connect the dots. Straight across. Zigzag down, zigzag up, straight across. You just composed two functions and you even graphed that composition. You all are some sweet, sweet pre-calc students. You need to tell yourself that right now. You guys are special. Nicely done. Hey, that's all I got for part 1. Hope you all have a sweet night. I will catch you later. Talk to you later. I'm out.